today we're going to learn about solving systems of equations through elimination. That's your learning target. You can solve systems of equation through elimination. Okay? Here's the steps. I'm just going to throw the steps at you. First, get one variable to be the opposite of another. Box off opposite. That is the key word in step one, opposite. Opposites would mean, and write this as an example, -2 and +2. Opposites. -10, and what's the opposite? +10. You need them to be the opposite. Also look at this keyword, eliminate. Well, if they're opposites, they eliminate. That's the foundation here, okay? Okay, and then you're going to add the two equations. Put a little cloud around add. So far we got the keywords of opposite, add. Then we're going to solve. So put a, I don't know, whatever you want around the word solve. And then we need to get the opposite one. We need to go back to the original. So I would just maybe write go back to where you started. So we have opposite, add, solve, go back to where you started. Opposite, add, solve, go back to where you started. This trick is sometimes they're not always opposite and you'll have to make them opposite, but that's always your goal. Make things the opposite because we want to eliminate, which is our learning target. Do you, on this first set of this first system of equations, system means two lines, two or more lines, and where they intersect. So here's the two lines. Do you see one variable the opposite of the other? Yes or no? Do you see 4 and -4? I see it. So I can combine them. I combine them by really adding them. That's truly what I'm doing. I'm adding them. 4 plus a -4 is how much?
0.
Okay, so that cancels out. 2 plus y, how many?
3y.
3 y's. 7 plus 2 is what? 9. What does y equal?
3.
3. So I know my y value. Now I need to go back. This is where it's not fun. I don't like linear combination for this going back part. Pick an equation. I have 2. I usually pick the one that doesn't have negatives or nicer numbers. It doesn't matter which one you pick. And I'm going to go back. This is a y. I'm going to go to a y. So put that arrow. Now I'm going to rewrite this whole first equation. 4x plus 2 times y. Y is 3. Equals 7. 4x plus 6 equals 7. You're going to get a fraction. I'm going to minus 6. That's just solving an equation. You do the opposite to solve. Minus 6 to both sides. You get 4x equals 1. Divide by 4 to both sides. X is 1, 4. So these two lines intersect at the point 1/4 and 3. Okay, we're going to solve the next system of equations. Do you see one that is the opposite of the other right now?
No.
Some of you say yes, some of you say no. Those of you that say yes, see the 2y and -2y. They can cancel out. Awesome. But my strategy, I like to look at the first number too. Those of you that said no, you looked at the x's. That will never get you in the wrong direction. I usually deal with that first x as well. So you could combine them right away. But if you like to cancel out that x, what do you want this to be the opposite of 3? What's the opposite of 3? Negative 3. So what do I need to multiply negative 1 by to get to negative 3? 3. But if I multiply 1 by it, I have to multiply the whole equation to ensure that it's still equal. So then I get this. You have to rewrite it because you want to be able to line things up. And then you distribute to everything. So I get negative 3x minus 6y equals negative 24. I hope you have room. You might need to rewrite them under because you got plenty of room going down on your notes. I'm going to move this. Okay, so that's me distributing. Now I have opposites. Do you see the opposites? So now I can combine them. Combine means add. 3 plus negative 3 is what? 0, so that cancels out. 2 plus negative 6. What's 2 plus negative 6? Negative 4y. The equal comes down. 12 plus negative 24, negative 12. Algebra says I'm going to have to divide by negative 4. So I will get a positive 3. This is a system of equations, so I have an x and a y. Now, I have 4 equations I can go back to. First one, second one, third one is the same as the first one, or the fourth one. You can put your y in any one of those equations. I usually do the one that has no negatives. So this is going to go right there. And again, I picked that because it doesn't have negatives. So 3x plus 2 times y is 3, equals 12. 3x plus 6 equals 12. Subtract my 6. 3x is what? 6. Divide. I should be writing all these steps down. I see some of you are nowhere near done. You have to write all these steps down. This is very hard math. Okay, next system of equations. Step 1 says I need to have opposites. So I have a positive 4, so the opposite of positive 4 would be negative 4. What do I need to do to 2? Geez, that's hard. What do I need to do to 2 to get to negative 4? Times it by negative 2. So if I'm going to change this equation, then I need to multiply everything through by negative 2. So show that. So I have my top equation, 4x plus y equals 24. I did not change that, but I do rewrite it because I need to be able to line up numbers to add them. Now I need to distribute negative 2 to everything. That would be negative 4x. This is a negative 3, right? Negative 2 times negative 3 is a positive 6y. Negative 2 times negative 2 is a positive 4. Now I can combine them. Combine means add. 4 and negative 4 cancel out. Y plus 6y is how many y's? 7y. 24 plus 4 is what? Y is 4. Halfway there. Now I have 3 or 4 equations that I can go back to. Again, I have the top one, the one that I started with, or the one that I ended with right here. I want to choose one with no negatives if I can, so I'm going to go to the top one. So the y is going to go there. I get 4x plus y is 4, equals 24. Subtract 4, that's algebra, I'm just solving. 4x is 20. Algebra says to move this 4, I would divide. So you get x is 5. So the solution to this system of equations is 5, negative, or 5, 4. That means that the lines intersect at the point 5, 4. Okay, so we left out the previous examples because I could multiply one equation to get the opposite of the other. Again, my main goal for step 1, I want opposites. That's my main goal. So I look at 2 and 3. What is a common factor of 2 and 3? I heard 2 people say it. I want to hear more people say it. 6. So I want to have 6 and I want to have negative 6. Those are the opposites that I want to deal with. So I don't know. I usually do negatives first, personally. What do I need to multiply 2 by to get to negative 6? Negative 3, yeah? What do I need to multiply 3 by to get to 6? 2. Okay, so now I'm going to distribute all in one. I'm going to distribute everything. Yep. Yep, absolutely. It doesn't matter. I usually do so Austin just asked, can he put the negative on the 2? Absolutely. I usually just do my negatives right away. Okay. So I'm distributing. I get negative 6x. Negative and a negative is going to be positive. So positive 9y equals 0. And then 6x minus 4y equals 10. I achieved my goal of opposites. Did you achieve your goal? Say yes. Yes, you did so good. Okay, now I can combine them. Combining that. Negative 6 plus 6 is nothing. 9 plus a negative 4 is going to be 5. 0 plus 10 is 10. Y is 2. Halfway there. All this work and halfway done. Love it. Now I have 4 equations to go from. First, second, third, or fourth. That you can put this y back into. I usually always deal with the top one. So I usually always just go back to the top. So this y is going to go right there. It's that whole equation. The equation 2x minus 3 times y equals 0. 2x minus 6 is 0. 2x is 6. X is 3. So these two lines intersect at the point 3, 2. Okay, so I'm going to solve this next system. I see I want opposites, so I can times 2 by a negative 2 because then I'll have a 4 and a negative 4. Distribute through, and I get negative 4x plus a negative 6y equals negative 2. And then I have my original bottom equation. Now I can combine them. Negative 6 plus a negative 2 is going to be negative 8y. Negative 2 plus 10 is 8. Y is negative 1. Now I need to get my x. So I need to substitute this back in. 2x plus 3 times negative 1 is 1.